Mohawk Trail Regional High School, Trinity College, Andover High School, also North Andover High School, both the stadium facility and the new baseball facility at Dartmouth College, Maynard High School's track, an award-winning project on behalf of Worcester Polytech just last year, turf and track. Slide, please. Some quick more. North Andover, Notre Dame Academy down at Hingham, another award-winning facility. We did a complete redevelopment of the Durfee High School athletic campus, the Franklin High School athletic campus. The second oldest synthetic turf field that we've done was at Marciano Stadium back in 2001, 2002. Slide, please. Framingham State, a project that was actually done in a floodplain of the Sudbury River. The very first infilled synthetic turf field of its type in New England was at UMass Lowell back in 1999-2000. I'm going to talk more about Fitzpatrick Stadium in a little bit because there's lots of similarities between that and your proposed project. Two award-winning projects, one in Wolfboro, New Hampshire, and a very ambitious scrape and rebuild of the athletic facilities at Roberts Field in Holyoke. Slide. Slide. That's quickly 24 examples, all done by Gail as the prime and in most cases only consultant on behalf, in most cases, of Massachusetts municipal high schools. With scopes very much comparable to yours, redevelopment of the track, bleachers, athletic lighting, public restrooms, facilities and concessions, and infill synthetic turf. Talk just a minute about your track. We've been on the track a number of times. We've taken a pretty hard look at it. I would call it in fair condition. It's not disastrous. It's not presently unsafe. On the other hand, its remaining useful life is very limited. It was originally constructed in '58. It had a full deck renovation in '97, so you've got an asphalt mat that's about 10 years old, 10 to 11 years by the time we get the project done. It is a latex surface, a rather inexpensive, rather unsophisticated latex surface that in that time frame has gotten very, very dry. The UV inhibitors have broken down. The rubbers have been unraveled. It's become brittle. The deterioration curve for this track, if you don't do something very soon, is going to fall off the table very quickly. And it will accelerate as you get moisture intrusion and as that surface continues to unravel a bit more. The inside lanes are worn differentially. Given its age, that's not atypical that the first and second lane, where most people, I get a kick out of people who do recreational running, they want to run a long distance, so what do? They hug the inside curb, and your track wears differentially. But often the case. There is some differential settling in the form of bird baths. After rain, you go out there a day later, there's still some puddling there, more than 1/8 of an inch in 10 feet, which is kind of the standard for tracks. And again, as is typical, the inside edge is breaking down and the asphalt mat is starting to deteriorate toward the inside lane line. The standard for High School Federation and MIAA is that you have 8 inches of offset between the inside lane line and the edge of pavement, and that's obviously to preclude ankle injuries as kids step off the track. That's breaking down, and there's some issues there. One of the biggest things in its original design is that there's only 6 lanes in the straightaway. As most of you who observe track know, the majority of your meet is spent running heats in the dashes and in the hurdles. 6 lanes does limit you from having large, significant meets, certainly any type of postseason meet, and is a limiting factor in the operation of the track event. It's much, much more important than 8 lanes on the oval. And finally, it's a fairly small radius track. I think, we haven't surveyed it, I think it's about 106-foot radius. That limits, the radius is the radius of curvature of each of the turns, and that limits the usable width of the infield. So although it was designed to accommodate a very good football field, it's rather limiting for soccer, which wants to be played at a greater width. It's fully compliant with the MIAA and the High School Federation requirements, which recognize that most high school soccer is played on adapted football fields, but it's still not optimal, and again, it's not something that would be suitable for postseason use. That's a quick glimpse of your track. Again, it's fair today, but you need to do something to it to make it better and sustainable for over time. Any questions about that before we go on? Yes, sir.
So you said it's to the point where the deterioration could be accelerating in the near term. My question is this: it was renovated, it's built in '58, renovated in '97. I've been involved in other track projects. I'm assuming at some point you have to dig it up. You can't just keep renovating and going over it and renovating and going over it, correct?
That takes me to my next slide, if I may.
Okay.
Any other questions? No, I'm not going to put you off at all. But you do have a couple of different repair strategies. Slide, please. I'm sorry, that's not where I thought we were going to be. But I'll talk about this first, and I will get to your question.
All right.
What you do to your track is related to the decision whether or not to install an infilled synthetic turf field, because the two meet at the edge of the track, and what you do with one has implications for how you do the other. Infill synthetic turf fields are basically built on existing material at this elevation, a filter fabric over the prepared subbase, drainage pipe and stone typically at 15 or 18 feet on center in a herringbone pattern to provide the under drainage, a 12 to 18-inch stone basin, which is a very free draining stone, very little fine material in that stone, it's very free draining over time, and a carpet on top, which is a tufted polyethylene, on top of which is dumped sand and rubber. Where natural turf fields drain laterally to the tune of about 75 or 80% of your flow is lateral flow, and hence you have a very crowned field, typically to 2–2.5%. Infill synthetic turf fields drain essentially vertically. So you've got a very robust under drainage system underneath to pick up that storm water and to get it away from your field quickly, thereby affording you a great deal of infiltration back into the groundwater, which is a very sustainable thing to do, and B, a field that is available virtually under all weather conditions. They are designed to pass about 16 inches of rain per hour, which is just an obscene amount of rain, never going to get there. The field is tied to a concrete anchor curb around its perimeter. It is a cast-in-place, reinforced steel curb. And that curb, you want to build it right because it's going to set the edge of your track and it's going to set the edge of your field for a very, very long time. Slide, please. So how does that come together? In profile, here's your field with the stone base and the under drainage. It comes to a concrete curb that has a slot drain, a polymer slot drain in it. And then you've got the structural filled stone base, 2 layers of asphalt, and the latex or urethane surfacing on top of the track. Again, the track meets the curb at the drainage basin, which then meets the carpet. And how that comes together has bearing on the gentleman's question. Because if we're going to blow this track up, if we're going to rebuild it, now is the time to do it. Because how do you form this concrete curb and the associated polymer trench drain in place with that track remaining in situ? You have to saw cut the edge to get a very straight edge, and then you have to excavate down 18 to 24 inches and hope that you don't undermine the existing asphalt mat while you form that curb in place. Slide, please. This is what it looks like going in. This is the structural base underneath the track. This is the free draining stone base underneath the field. This is the grated trench drain in a reinforced concrete curb where it all comes together. If you're building the track and the field at the same time, this is a very straightforward detail. On the other hand, if you're trying to preserve the track, which is an option, and I'll talk about that, it makes this detail a bit more of a challenge. Not undoable. We did that detail in Wayland. We did that detail at Boston College High School and a number of others with the track to remain. Slide, please. Slide, please. This is after the dense graded stone base has been put down and the paving has been paved up to the edge of the polymer trench drain. This is the D area, or inside the turn of the track. This is the straightaway of the track, and this is the field side. That's where it all comes together. Slide, please. But we can renovate the track. Repair alternative number 1, and again, these numbers that I'm showing are for purposes of relativity. These are pre-design numbers and certainly subject to change. Having said that, they're pretty good numbers. We could remove the existing surface by milling it off. We could clean and repair the asphalt mat, which is now 11 years old at this point. We could apply a tack coat and a new latex surface and restripe it. The cost of that is about $75,000. Publicly bid prevailing wage. In addition to that, if you're going to do an infilled synthetic turf field, there's the question of the D area, the area between the end of the end zone and the outside of the turn. And what do you do with it? The typical thing to do is pave it and put track surfacing down. That at a cost of another $125,000, and that number is going to stay the same in each of these options. Everybody with me? Super. Slide, please. A second alternative, which is a bit better, is to do the same repair. It's to mill off the existing asphalt, latex, to do the same repairs, crack repairs, fill the bird baths with a leveling course, and then to put a 1-inch lift of new asphalt over the whole thing. That's going to give you a little bit more longevity. It's going to extend the useful life of the track to probably 15 years, assuming that you resurface it and restripe it every 6 or 7 years. And it's going to cost a bit more at $120,000. Again, we also want to pave the new D areas and surface those to match the resurfaced track. Slide, please. And finally, the repair alternative, which I think is appropriate, but it's a question, it's not my money, it's your money, is to pulverize the track, to do a full depth blending of the resultant material from the pulverization, to recompact it, to put 3 inches of new asphalt down, a new latex or urethane surface, and to recoat it and restripe it. Yes, sir.
Would that expand it to 8 lanes instead of 6?
That's right. You guys are just taking me where I want to go. Slide, please. The advantage to that is that, first of all, you're going to have a better than new facility. Because you've got all that asphalt that's mixed into the subbase, you've got a denser base for the track, you've got 3 new inches of asphalt, and you've got a couple state-of-the-art materials. One of these is latex, one of these is urethane, one would be the base bid, one would be the alternate. I'll let you figure which is which. But a much better surface than is down today. It would give you the ability to develop 2 additional lanes in the straightaway. Because we're not stuck with that geometry, and also I'm going to change the orientation. I'm proposing that you would change the orientation of the track a little bit. It's going to free up an additional 2 times 42 inches worth of width that we can get 2 additional lanes in the chute and make it a much better functioning track and field facility. It gives us the ability to change the track and field orientation. What do I mean by that? Most of you have seen this graphic previously. It is a cartoon. It's not a designed document, but it's our initial thoughts with regard to how we might make it a better facility. The way we make it a better facility is take advantage of some of the dead space that's out here by swinging it to be a bit more parallel with the road. That's going to free up some space in here. We also think we can move these bleachers out such that the elevated deck of the front edge of the bleachers is tangent with the with the fence line, and have a rearward exiting set of bleachers. Between those two things and stuffing the bleachers back a little bit, making them a little bit thinner and a little bit higher, we can get the additional width that we need for the additional 2 lanes. But in the absence of blowing up the existing track, we don't get to reorient it, and we don't get to change the geometry such that we can accommodate those additional 2 lanes. Great question.
What about increasing the width of the football field so that you can accommodate soccer?
That's my next line. This is great. I like this. Ability to open up the infill width. The thing that we think we can do a little bit of, not a lot, and that's why I put limited. We think we can probably gain a couple more feet worth of radius. That's going to translate to about 4 feet of additional width. But in the corner kick areas, that's a very important 4 feet. And that's what we're thinking.
And is that only if you go with option 3 and totally?
Clearly, yes, because the limiting width of the infield is the existing radius of the track, which is a relatively narrow radius. So that's exactly right.
Now, just so with this, you're talking about completely removing the visitor grandstands that we have right now, correct?
Thank you, I missed that point. Yeah.
Not that we need them, but
one of the things that is implicit here is that, like most public high schools are going to now, we're going to a very well constructed, very well laid out, ADA accessible, building code compliant, structurally compliant, life safety code compliant